I'm going to start off this video a little bit different. We're not actually going to code at all in this video. I'm just here to explain a topic that's going to follow us through the rest of the class. So to start off, I'm going to ask, did you eat toast for breakfast? And you can kind of answer to yourself. Obviously, I won't be able to hear you. I'll ask questions and I'll kind of describe how they apply to me. So I do often eat toast for breakfast. So I'm going to say yes. What kind of bread was it? For me, I toast sourdough bread. That's like all I buy at the grocery store. Where's the toaster in my apartment? It's in my kitchen on the counter. My toaster happens to be kind of a green toaster, but I couldn't find a green toaster online, so I found this nice generic picture of a toaster. There we go. There's a toaster. Mine looks vaguely like this. My toaster has kind of two slots in it. It's got this little thing that you push down to actually push the toast down, and a dial with numbers on it to decide how much the heat turns up. That's about how my toaster works. If you asked me kind of in-depth information about my toaster, I can answer some questions, but not all that many. Like, let's say I asked you, there's coils inside your toaster. Do you know how many rotations are actually in those coils? I definitely don't for my toaster. If you actually asked me in-depth how my toaster works, I have no idea. Hypothetically, I found this little diagram that talks a little bit about what's going on in the toaster, but I wouldn't have known any of this. Isn't it really this wonderful thing that we can toast a piece of bread and not actually understand fully how our toaster works? And that's kind of the key to the idea we're going to talk about, is that you shouldn't necessarily have to understand a system to be able to use it. If I want to toast a piece of bread for myself, I shouldn't have to understand things like how much voltage needs to be sent through the wires in my toaster to heat it up to the optimal amount, or how much power draw comes from my toaster, or how many coils are on the inside wires of my toaster. I shouldn't need to know that information to be able to actually just make bread for myself. Who actually has to be the one who worries about how the toaster works is probably the person who built the toaster in the first place, whether it was some engineering team or some kitchen appliance team or something like that. That person definitely is worried about how the toaster is working. But me, a random person just toasting my bread, I do not have to worry about how the toaster is working. In this class in APCSA, that big idea that you don't really have to worry about the inner workings of a specific piece of machinery, or in this case, a piece of code, or we're going to say an object, the fact that we don't have to worry about the inner workings is this idea of something called an abstraction. It's something that you can use without understanding the specifics of how it works. In this case, how do I actually have an idea of how my toaster works? I put toast in, I push down the lever, I switch the dial, and my toast gets toasted. And that's about all I need to know. Over the next few examples, we're really going to be heavily working with this idea of abstractions, and specifically this idea in Java of a class. I don't mean class as in like APCSA is a class. We'll see what class means in terms of the Java programming language, and actually most programming languages. All right, let's take a look at another example of an abstraction though. And for this one, I'm going to talk a little bit about driving to school. For you, did someone drive you to school? Do you drive yourself to school? I drive myself to school, and specifically I have exactly this car, which is a Chevy Bolt. Just because I'm driving doesn't mean I actually have a great understanding of how my car works. I have some understanding, obviously, of I turn the steering wheel, I push the brake, and I push the gas, and things happen. In a gas car, there's some sort of combustion. In an electric car like mine, it's a little bit different, right? This is about the understanding of what I know about my car, which is pedal means go, pedal means stop. But there's actually, again, there's this crazy inner working to how electrical vehicles work. The world is actually super complicated, and we know that. And it is this kind of wonderful thing that we're able to use things without fully understanding how they work. If all of us had to be proficient in the inner workings of a car to be able to drive a car, there'd be far fewer people driving cars because it's pretty dang complicated. Let's look at one more example, which is the App Store or the Google Play Store, depending if you're kind of a Android or iPhone user. We've pretty much all at some point downloaded an app, unless you're one of those people who's archaic and does not use a smartphone. That's also pretty cool. But if you're a smartphone user, I am a smartphone user, I have an iPhone. I've definitely downloaded apps from the App Store. Have you ever thought about what actually happens when you download an app? You kind of click some button that says download, and then boom, there's an app on your home screen. But the App Store itself is an abstraction. When you actually click that download button, there's an app that appears, but there's a lot of stuff happening in the background. Like, let's say you have to purchase that app. There's some information that has to link your credit card or your bank account to be able to send funds to the correct person, potentially transferring currency. And there's a whole lot actually going on behind the scenes when you purchase an app. Obviously, there's a software download onto your phone. And it's actually, again, this wonderful thing that we don't have to understand how this works at all. Who actually, in this case, has to understand how it works is the engineers at Apple. They have some conception of how to make an app. And I love that when I Googled image of how app is made, this is what popped up. This is exactly what I imagine making an app feels like. It's great, though, that we don't actually have to worry about that. Someone made an iPhone with an app store, or someone made an Android with a Google Play Store, and that thing just works. And we don't have to worry necessarily about what happens when I push that button to download Flappy Bird, besides the fact that Flappy Bird will then appear on my phone. So again, this idea of an abstraction, this slightly black box unknown thing that I can understand how to interact with, but I don't need to know the specifics of its inner working. That image of a black box where I kind of know what things I can do to the box, but I don't know what's happening inside of the box, is actually a pretty good metaphor for this. So we're going to be working with different abstractions throughout this class, throughout the entire year, but especially pretty heavily in the next few examples. And like I said, in Java, the idea of an abstraction is represented by this thing called a class, which we're going to talk about in a lot more detail now.